Hello, my phenomenal viewers, and welcome on to this episode. On today's episode, we are going to be answering this question, and the question reads: the equations of two cycles S1 and S2 are given by S1 is such that x squared plus y squared minus 4x minus 6y minus 3 is equal to 0, and S2 is such that x squared plus y squared plus 8x plus 10y is equal to negative 5. Show that S1 and S2 touch and determine the nature of touch. So as you can see, the question is under cycles, and we've been given the equations of two cycles, S1 and S2, for us to show that these two cycles touch, and for us to also determine the nature of touch. That is, do the two cycles touch internally or externally? Now, before we dive into answering this question, I would like us to look at the conditions that must be met for two cycles to either touch internally or externally. So when we have two cycles, for these two cycles to touch internally, then there is a condition that must be satisfied by the two cycles, which is the distance between their centers must be equal to the difference between their radii. What does this mean? If I have a cycle, say this is a cycle, and another cycle touching it internally, I know that the cycles are not accurate, but permit me to use these two cycles to explain what it means by two cycles touching internally. So this is the center of the larger cycle, then this is the center of the smaller cycle. So call this C1, call this C2. Then we know that from the center to any point on the circumference of any cycle, it is the radius of that cycle. So from here to here is R2 for the smaller cycle. Then from here to here is R1 for the larger cycle. Now you notice that this distance between C1 and C2, which is the distance between the two centers of these cycles, is the same as the radius of the larger cycle minus the radius of the smaller cycle. So D, which is the distance between their centers, is equal to what? R1 minus R2. So when this condition is satisfied between two cycles touching, then we see that they touch internally. Now for external touching of two cycles, the condition that must be fulfilled is that the distance between their centers must be equal to the sum of their radii. So if I have two cycles like this, and another one like this, so they are touching externally. Excuse me. This is the center of this cycle C1. This is the center of this other cycle C2. Then this is the radius R1. This is the radius R2. So you can see that the distance between their centers from here to here is the sum of their radii. So D in this case is equal to R1 plus R2. If this condition is met for two cycles touching, then we see that the two cycles are touching externally. So I wanted to draw our attentions to these two conditions because we are going to use both these two conditions to prove or determine the nature of touch, whether they touch internally, that is, they are touching like this, or externally, that is, they are touching like this. So if we've seen the conditions that must be met for two cycles to what, touch internally or externally, let us go back into showing that the two cycles touch, because if they don't touch, then all of these two conditions are not going to be fulfilled. So coming back to the question, we have solution. The equation of S1 is such that x squared plus y squared minus 4x minus 6y minus 3 is equal to 0. So looking at the equation of S1, you can see that it is not in standard form. Now, why is it not in standard form? Because it is not written in this form, which is what? X minus a all that squared plus 1 minus b all that squared is equal to what? R squared. Whenever an equation of a circle is given in this form, then this is the standard form of the equation of that circle. So for any circle to be in standard form, then it must be written like this, where the points a, b is the coordinate of the center, and r is equal to the radius of the cycle. So since this equation is not in standard form, how are we going to standardize it, or how are we going to make it to be like this? We are going to standardize this equation by using the method of completing the square. So I'm going to complete the square for x and also complete the square for y. So how am I going to complete the square for x and y? For me to complete the square for x, I will simply take the coefficient of x divided by 2. I will square it, then add it on both sides of this equation. Remember, this is an equation. So I will have x squared minus 4x. You can see that the coefficient of x is what? Negative 4. I will divide it by 2. That gives me what? Negative 2. Then I will square it and add it on both sides. So I have plus negative 2 squared. I'll write it like this. I'll do the same thing for y. I have y squared minus 6y. What is the coefficient of y is negative 6. Negative 6 divided by 2, that gives me what? Negative 3. I will square it and add it on both sides. This gives me what? Plus negative 3 squared is equal to, remember, this negative 3 causes the equal to sign and becomes what? Positive. So I have 3 plus negative 2 squared plus negative 3 squared. So I've added negative 2 squared on this side. I've added negative 2 squared on this side. The same negative 3 squared on this side. Negative 3 squared on this side. Now, this shows that S1 is such that I will have x minus 2 all this squared. Now, I'm just going to write out the terms that are squared. So I have what? X is squared. I write x. Then negative 2 is what? Squared. So I pick out negative 2. So I have x minus 2. Now all that squared. Plus y is squared. Negative 3 is squared. All that squared is equal to 3 plus 4 plus 9. That gives me 16. So I have what? 16. Which is the same as what? 4 squared. 16 is 4 squared. Maybe I'm trying to minimize the board since the board is not that large. So you can see that this equation is now in standard form because it is now written in this form. So it shows that S1 has radius. So R1 in this case is what? 4. Then C1 is, if it is negative, it becomes positive. If it is negative, it becomes positive. If it is positive, it becomes negative. So the coordinates of the center of C1, we have the x coordinate is what? 2. The y coordinate is what? 3. I will do the same thing for what? S2. I'm going to standardize S2. So I have S2 is such that x squared plus y squared plus 8x plus 10y is equal to what? Negative 5. So I'll do the same thing. Have the coefficient of x. I will square it, add it on both sides. So I'll have x squared plus 8x. The coefficient of x here is 8. 8 divided by 2, that gives me 4. I'll square it, add it on both sides. Plus 4 squared. I'll have plus y squared plus 10y. Then have the coefficient of y, which is, the coefficient of y here is 10 divided by 2. That gives me 5 squared, added on both sides. So this gives me negative 5 plus 4 squared plus 5 squared. So it shows that S2 is such that I'll do the same thing. I just write out the terms that are squared. X plus 4, all that squared, plus y plus 5, all that squared is equal to, when you sum this is negative 5 plus 16 plus 25, that gives me what? 36, which is the same as what? 6 squared. So it shows that R2, which is the radius of S2, is 6, and C1, which is the center of C2, which is the center of S2, is negative 4, negative 5. So since we have the radii of S1 and S2 and the centers of C1 and C2. We now need to determine the distance between these two centers and see whether is it the same as the sum of these two radii or the difference of these two radii. Now, how do we determine the distance between 2 points? The distance between 2 points, which is d, is calculated using this formula. D is equal to x2 minus x1 all that squared plus y2 minus y1 all that squared. So we are going to use this formula to determine the distance between the centers. So d is equal to square root of, if I take 2 minus -4, so I have 2 minus -4 all that squared, plus if I take 3 minus -5, 3 minus -5 all that squared, this gives me d to be equal to the square root of 6 squared plus 8 squared. So d is equal to the square root of 36 plus 64, which is the square root of 100. Therefore, d in this case is equal to 10. D is 10. So the distance between the centers of these two circles is 10. Now, it shows that for us to have the distance between the two circles to be what, 10, we need to what, sum their radii. If I take 4 plus 6, that gives me 10. So it shows that these two circles touch externally, because since d is equal to 10, which is equal to what, arc1 plus arc2, comma, s1 and s2 touch externally, as I explained earlier. So the two circles touch externally. Had it been that this 10 is the difference between the two radii, then we conclude that the two circles touch internally. So this is how you go about answering this question. Okay, if you loved this video, please help me and share so that I can get to many students as possible. And if this is also your first time coming across any of my videos, please do not hesitate to either subscribe or follow me, so that whenever I upload videos like this one, you would be notified. And thank you for watching. Stay blessed.